In this video, we're going to do example 2. You might notice that this starts with x to the third, which is slightly nicer than starting with x to the fifth. It means we're not going to have to do as many cycles to get to our final answer. Using the fundamental theorem of algebra, the largest exponent 3 is the number of possible solutions. Using Descartes' rule of signs, look at the number of sign changes. We start positive, we change to negative, and then change back to positive. So that means there are 2 sign changes. According to Descartes' rule of signs, it's the number of sign changes or less by 2. So that could be 2 or 0 positive solutions. The number of solutions has to add up to 3, so there's 1 possible negative solution. Those possible solutions are the factors of 15. So 1 times 15 and 3 times 5. So 1, 3, 5, and 15 are the possible solutions that we need to test. There is a large possibility that we are going to have 0 positive solutions. So we want to test the negatives. Now previously, if you didn't pay attention to Descartes' rule of signs, you would still get your answers because all of our answers were real numbers. But now, some of our solutions are not going to be real numbers. So we really have to pay attention to Descartes' rule of signs. And you want to focus in on the guaranteed solution. You are guaranteed 1 negative solution. So if you test the negatives, you're guaranteed to find the solution. Okay, to set up the synthetic division to test these solutions, our coefficients are 1, 1, negative 1, 15. And we're going to start by testing negative 1. So drop your 1 down, multiply, add, multiply, add, multiply. Negative 1 is not our solution. So I'm going to erase that and erase this stuff out. Or redraw your synthetic division if you want to. Next I'm going to test negative 3. Multiply, add, multiply, add, multiply. We got a remainder of 0. This means negative 3 is a solution, and our factored form is x plus 3. The result of the synthetic division is the other part of this. Let's see, I'll use green. So this becomes this set of parentheses. Because we started with x to the third, we divided an x out of it. Now we have x squared minus 2x plus 5. This is very similar to what we did in section 4.5. This should look exactly like what we've been doing. Next, we would try to factor the green set of parentheses. The problem is, if we're looking for 2 numbers that multiply to 5 and add up to negative 2, you're not going to find a pair of numbers that do that. You could do 1 times 5, and that's it. And there's no way to add up to negative 2 using 1 and 5. So this is not factorable. But that's not going to stop us because we have the quadratic formula. So here's that quadratic formula. Your a value is 1. Your b value is negative 2. Your c value is 5. You need to plug it into the quadratic formula, which is right up here on your screen. So, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. The quadratic formula is not that difficult. You just have to put the correct numbers in the correct place. And if you have the quadratic formula in front of you, and you've labeled out what is your A, what is your B, what is your C, should be pretty easy. The one thing to really remember, when you square your B value, even if your B value is negative, when you square something, it becomes positive. My suggestion would be put parentheses, whatever your B is, close your parentheses, square it. Do that whole thing in your calculator. So B squared minus 4AC, do that in your calculator. If you do this in your head, negative 2 squared is positive 4. Positive 4 minus 20 is negative 16. Did I do that correctly? 4 minus 20 is negative 16. So we have 2 plus or minus the square root of negative 16 divided by 2. Think about the square root of negative 16. That splits into the square root of negative 1 times the square root of 16. The square root of 16 is 4. The square root of negative 1 is I. So this is 2 plus or minus 4I divided by 2. This can be simplified. You have to look at the whole number pieces, the 2, the 4, and the 2. Divide all of those by 2. This becomes 1 plus or minus 2I. 2 divided by 2 is 1. 4 divided by 2 is 2. So this is your solutions. I say solutions because it's plus or minus. So 1 plus 2I is one solution, and 1 minus 2I is another solution. Now, that's the result of doing the quadratic formula, which came from the green part that we couldn't factor. We still have this x plus 3. The solution that comes from x plus 3 is x equals negative 3. So our solutions are x equals negative 3 and x equals 1 plus or minus 2I. If we go back to Descartes' rule of signs, this problem told us that we could have 2 real positive solutions or 0 real positive solutions. And that is true here. We ended up having no positive solutions. If we would have checked positive 1, positive 3, positive 5, positive 15, we would not have found our solution. Descartes' rule of signs is super important to make sure that you're finding your solutions. We were guaranteed one negative solution, and we got that negative solution, x equals negative 3. We were not guaranteed a positive solution. We didn't get any positive solutions. We got 2 imaginary solutions. So today, this is really just taking what we've been doing before a little bit farther and involving the quadratic formula and some imaginary solutions. So it's pulling from things that we did last semester and pulling from things that we did in the last section. For your assignment, I would like you to try example 3. Example 3 is actually super easy. It doesn't involve the quadratic formula. I believe after you do synthetic division, you can factor just normally. Then there's one problem out of the book that I'd like you to try that is similar to example 2 that we just did together. So try those 2 problems, see how you do. We'll talk about it tomorrow, and we will have plenty of work time to practice this stuff tomorrow.